Hello everyone, myself Sachin Fiske from Electrical Engineering Department, S&D College of Engineering and Research Center. Today we are discussing the point on PLC, overview of this PLC and its applications. Now, before going to this point, first we discuss about industrial automation. What is automation? Okay, so automation is encompassing virtually every walk of life. Then automation solutions are required right from agriculture to the space technology. A plant automation basically need for the necessity of the manufacturing industry to survive in today's global competitive market. And what is automation? So automation is basically the delegation of a human control to the technical equipment. Basically, these automation technologies can increase the productivity of a human life. Then the industrial quality of the material system can also be increased by using automation system. So different types of automations are also available. It reduces the cost or manpower of the operating system. Then again increasing the safety in a working condition. So basically we are taking an example of the induction motor or three-phase induction motor. The implementation of monitoring and control system for this induction motor based on PLC technology is described in this topic. Also, the implementation of a hardware is nothing but the PLC, and software for the speed control technologies will be discussed here. This PLC technology have been rapidly increasing and proving its result in the field of automation engineering, and beneficially it can show the result as compared to the various methods of the speed control, that is speed control by using the armature control. Basically we are taking this V by F control system here, and the major important point is that the normal efficiency of a three-phase induction motor, if we consider practically, then it is 60 to 70%. But by using PLC system here, we are going to control the efficiency up to 95% of the synchronous speed. In this topic, we are starting from PLC overview, then historical background of the PLC, some objectives of the PLC, complete block diagram of the PLC, leading brands of the PLC, it is software brands, then selection criteria of the PLC and some applications of the PLC system. Moving towards the definition of the PLC system. So what is PLC? Basically, this PLC is nothing but a programmable logic controller. It is a solid state member of a computer family, and it uses the integrated circuit instead of electromechanical devices to implement the control functions. Now, what is control function? So control functions are basically a sequencing, timing, counting, arithmetic data manipulation, then communications to control the industrial machines and processes. Also, the programmable logic controller are called as programmable controllers or PLC, and these are the solid state members of a computer family. This PLC system monitors the input which makes the decision based on its program and controls the output to automate a process or machine system. This PLC is a computer-based device that controls the industrial equipments and processes, initially designed to perform the logic functions executed by relays, drum, switches, and mechanical timer counters. It has also been extended to analog control as well. A typical PLC system consists of a processor and input-output system all mounted in a rack and chassis system. This PLC system is a cost-effective solution with the applications such as high ratio of the digital to analog point in a particular system. And there are numerous third-party vendors supplying the software packages that allow the PLC to be interfaced to a PC-based operator interface packages. It is a user-friendly microprocessor-based specialized computer that carries out the control functions of many types and level of the complexity. Basically, its purpose is to monitor the crucial process parameters and adjust the process operation accordingly. And it can be program controlled and operated by a person unskilled in operating the computer, but who is the PLC literate only. The PLC operator develops ladder diagram, which is then converted into a computer machine language and runs as a user program. There are some advantages of this PLC system, but we will be discuss it later. Okay. Again, one more point. We are moving towards the historical background of the PLC system. So the approval of this PLC system was first developed in 1968. Starting from 1968, the first early machines were controlled by the mechanical means using cams, gears, levers, and other basic mechanical devices. As the complexity grew, so did the need for a more sophisticated control system. And this system is contain a wired relay switch control element. These elements were wired as required to provide the control logic necessary for a particular time or model, but as manufacturing technique improves and plant changeovers to new product become more desirable and necessary, a more versatile means of controlling this equipment had to be developed. This hardware relay means switch logic was cumbersome and time consuming requirement. This modification was difficult and time consuming to design and install any small bugs in the design that could be a major problem to correct, since that also required rewiring of the system. A new means to modify the control circuitry was needed. The development and testing ground for this new means was first developed by the US auto industries, and the time period for the late 1960s and early 1970s, and the result was the programmable logic controller. In this way, this PLC was developed. Now, the first PLC was developed by the hydromatic divisions of the General Motor Corporation and specified the design criteria for the first program controller in 1968. Their primary goal was to eliminate the high cost associated with inflexible relay control system, and the specification basically required a solid state system with computer flexibility able to survive in the industrial environment. It should be easily programmed and maintained by a plant engineer and technician. Also, it should be reusable. Then such a control system would reduce the machine downtime and provide expandability for the future. Then some of the initial specification would include as a new control system had to be price competitive with the use of the relay system. Secondly, the system had to be capable of sustaining an industrial environment. Again, the input and output interfaces has to be easily replaceable. Then the control had to be designed in a modular form so that the substitutability could be removed easily for the replacement or repairing of the PLC system. The control system needed the capability to pass the data collection to a central system, and the system has to be reusable. The method used to program the control had to be a simple so that it could be easily understood by the plant personnel. Now, the product implementation to satisfy this hydromatic specification was underway in 1968, and by 1969, the programmable controller had its first product offspring. The first PLC offered by relay functionality, thus replacing the original hardware relay logic which used electrically operated device to mechanically switch electrical circuits. They made the requirements of modularity, expandability, programmability, and ease of the use in an industrial environment. In 1972, the introduction of the microprocessor chip increased computer power for all kinds of automation systems and lowered the computing cost. In 1980, with more computer power available, the PLC came into the exponential increasing use. The market for PLC is today close to $1.4 billion. Also, the PLC function such as speed of operation, type of interfaces, and data processing capabilities have improved throughout the year, and their specification still holds to the designer originally intentions. They are simple to use and maintain. So many technology advance in the programmable logic controller industries continues today. These advantages not only affects the programmable logic design, but also a philosophical approach to the software upgradation. Some describe some recent PLC hardware enhancement are as faster scan time being achieved using new advanced microprocessor and electronic technologies. Now moving towards the point, in 1974, several processors within a PLC having the timer and counter will be implemented. Then arithmetic operations can also be performed, and the size of 1K of the memory is now upgraded to 12K of the memory, and 128 IO points will be increased towards 1024 IO points. In 1976, a remote-based input-output system was introduced in the PLC system. In 1983, a small size PLC will be introduced in the system, and in 1985, a remote location networking based PLC level has been introduced in the system with some SCADA software, means the result can be obtained from the system locations. The monitor of the PLC system can be controlled from any location, that is a remote location can be used for this PLC system. There are some objectives why these PLCs can be used in a continuous system. Okay, so basically here we are taking an example of the speed control of the induction motor by using the PLC system. So to control the speed of the induction motor by using PLC, secondly to control the torque of the system, then to maintain basically efficiency up to 95% as discussed earlier of the synchronous speed, and showing all of these results in a SCADA screen. So these are some points related to the PLC, means some components of the PLC. Basically, PLC composed of 5 major parts. First one is the power supply. Second one is programming devices. Third one is a processor. Again, input and output modules are there. So moving towards the basic operation point of the PLC, that is power system. So this PLC consists of major blocks as a power supply. The power available in most of the plant is 230 volt AC 50 Hertz supply. Most PLC operates on plus minus 5 volt DC, and therefore the PLC CPU must contain a circuitry to convert 230 volt AC input to the required 5 volt DC value. It basically consists of 4 blocks. The first block is the line conditioner. Then it consists of some remote values and any distortion in the sine wave available at its input. The second block is the rectifier, which converts AC to DC. Basically, rectifier required to convert the value available into the AC to the required DC. And third block is a filter, which comprises of resistance, inductance, and capacitor. This filter accomplishes the requirement of the smoothing. And the last block is the regulator, which requires the DC voltage to 5 volt regardless of the load demand. Second block is the processor. Basically, CPU or processor are the same. General personal computers also have the CPU, and the CPU basically has 3 major parts, that is microprocessor, memory, and power supply. The CPU makes the decision and executes the control instruction based on program instruction in the memory. The central processing unit governs all the PLC activity, and during its operation, the CPU completes the 3 major processes. That is, it reads or accepts the input data from the field devices via the input interfaces. Secondly, it executes or performs the control program stored in the memory system. And thirdly, it writes or updates the output devices via output interfaces. This process of sequencing the reading input, executing the program in the memory, and updating the output is known as scanning. This is generally a processor-based program, and total memory is broken into the various types, that is EEPROM, then battery backup RAM, and E2PROM. A mathematical processor is useful in addition for any complex mathematical calculation. Also, the communication ports used for this system is 2 or 3, that is RS232, RS422, RS485 is also provided. Then solid state memory is attempted in case of the PLC system. So various types of the memories are available. Let us see one by one. The memory system is the area in the PLC CPU where all the sequences of the instruction or the program are stored and executed by the processor to provide the desired control of the field devices. The memory section that contains the control program can be changed or reprogrammed to adapt the manufacturing line procedure changes to new system startup requirement. Basically, 2 more memories will be added, that is the executive memory and the application memory. What is the executive memory? It is the collection of the permanently stored programs that are considered part of the PLC itself. These supervisory programs direct all the system activities such as execution of the control program and communication with the peripheral devices. The application memory basically provides the need for storing the data area for user program instruction that forms the application program. The application memory area is composed of several areas, each having a specific function and usage. Again, some different types of memory are ROM, RAM, then program read-only memory, that is PROM, erasable programmable read-only memory, that is EEPROM, again electrically erasable programmable read-only memory, that is E2PROM. So all these points are basically known to everyone. Microprocessor and microcontroller basically consist of all these points. Now, what is I/O modules? The devices which to be controlled are based completely on the input modules, and the devices which are to be controlled are completely based on the output modules. So digital I/O module performs four tasks electronically. First, it senses the presence or absence of an input signal at each of the input terminal. Secondly, it converts the input signal for high or on to a DC level usable by the module electronic circuit. And for a low or off input signal, no signal is converted, indicating it is off. Thirdly, the input module carries out electronic isolation, not electrical isolation, but it is the electronic isolation by electronically isolating the input module output from its input. Again, finally, its electronic circuit must produce an output via output logic to be sensed by the PLC CPU. These input and output devices, that is I/O modules, which are to be connected to the electrical equipment, are often connected in what is known as syncing or sourcing the circuit. So what is syncing and sources? If a solid state device is control the current from the load side, got it? From the load side, then it is called as syncing devices. On the other hand, if the solid state devices control the current to the load side, then it is called as sourcing of the devices. In the former case, the load is connected to the negative side. Again, I am repeating. In a former case, the load is connected to the negative side of the power supply, and in latter case, the load is connected to the positive side of the power supply. A current source output will be used as a PNP transistor and one requiring a negative voltage to turn it on. A current sinking output will employ an NPN transistor, one requiring a positive voltage to turn it on. Then some discrete input modules are also available, and AC or DC input circuitry has basically a two primary parts, that is lower power section and logic control system. Okay. A single-ended input suffers from loss of common mode rejection and are very sensitive to noise, and hence the analog input are connected in a single-ended configuration generally when they are to be used only for the purpose of the data acquisition. Two different input provide the communication noise immunity, and therefore the analog input are connected in different configuration when both the data acquisition as well as precise closed loop control operation is prescribed. See this is the PLC configuration for Allen Bradley brand. There are some major brands that is available in case of the PLC system. This CPU will show here, and some external power supply is also given, but this CPU will start to operate when external power supply is given only. After that, CPU will perform some activities, means it reads the data from the input interfaces, then it executes, and then it will write to this output module. Some input and output modules will be provided here one by one. There are some different structure as per their brands. Okay, so this Allen Bradley brand just look like this one, and some internal features are also provided here. See this, these blocks, these empty blocks will be provided for the communication purpose, means by using the port just like RS232, RS485 will be connected here to monitor this system. Okay, see here, this PLC will be provided. This PLC has two sides, one is LHS and second one is RHS. So the input modules are connected on LHS side and output modules are basically connected on the output side. So these are the input modules and these are the output modules. Means basically whenever we are going to connect any machinery, these are connected on the RHS side of the PLC, and these devices to be controlled which are connected on the primary side, that is input modules of the PLC. It is very basic configuration of the PLC system. Some leading brands of the PLCs are American brand, then European brands, and some Japanese brands are also available. American brand includes Allen Bradley, Gold Modicon, Texas Instrument, General Electric, Westinghouse, Cutter Hammer, and Square D. And some European brands are Siemens, Nockner and Mauler, Fesco, and Telemechanics. Japanese brands like Toshiba, Omron, Mitsubishi, and Fanuc are also available. Besides this, some Indian brands are there, just like Motorola, L&T, ABB, again Delta, then Starcom are also available. So before going to market for purchasing any PLC, some PLC criteria should be known. That is the number of logical input and output. Be the number of logical input and output are more, you can use the same PLC in future also. The size of the memory should be very high so that in future for storing the data we can use the same memory. Means no memory can be extendably we have to use. Third point is that the number of special IO modules. IO modules is just same as that of the input and output modules. Then scan time will be very short. For scanning any of the execution of the program is very less, so that it can save more and more time. And the communication should be very easy. Basically, RS-232 port can be used and RS-485 port can be also be used. Also, the software should be easy and upgradable so that no need of a new software to be installed for upcoming generations. Thank you.